it is the way.
So, good morning, good afternoon, and good evening, everyone, wherever you are. I welcome you all to this webinar, which is, I think, the 7th webinar delivered by Ayala to a wider audience. So far, we have covered a number of interesting topics, which all have been well received. And we will continue this effort for a while during this unusual situation, and maybe beyond. My name is Omar Fritz Eriksson, and I am the Deputy Secretary General of Ayala, as well as the Dean of the Ayala Worldwide Academy. So this webinar is the first one of 4, which will inform you about the most recent outcomes of the work of our 4 technical committees. We have about 300 members, 87 of which are national members, and we have a lot of industrial members and associate members, and they all participate or have the possibility of participating in these technical committees, where we develop guidance for our membership. The committees have a 4-year work cycle where they put a lot of effort into developing standards, recommendations, and guidelines. In the context of marine aids to navigation, the recommendations tell us what one should do when providing marine aids to navigation. Mikael Hoppe, could you please turn off your video and your microphone, please? Africa, also you, microphone off, please.
Sorry.
So I would urge everyone to turn off their microphones and the cameras in order to preserve bandwidth and avoid interruptions to the speakers, please. So the recommendations tell us what one should do if providing or when providing marine aids to navigation services. And the guidelines tell us how to go about it, describe best practices and solutions that allow you to achieve what you want to do. Standards talk about which recommendations are normative and which ones are informative. We will perhaps have a webinar on all this later. So once the committees have developed a document, our committees approve it as 100 people or 150 people even participate in these committees, and they agree on the output. That then goes to the Ayala Council, which then scrutinizes the results and approves it in due course, whereafter it can be published as an Ayala publication. We will proceed with the presentations planned for this webinar and have a question and answer session after the presentation have been made. The webinar will be recorded and made available on the Ayala YouTube channel in a day or 2 maximum. And if you have any questions during the presentations, you can note them down on a piece of paper, or you could also note them down in the chat channel of this meeting. Virginia, you are beautiful, but please turn off the the video camera. So today's program is we have 3 speakers today, and the first speaker is Minsu Jion, who will talk about the Ayala standards, recommendations and guidelines, and some updates on the document. Magnus Valhagen, welcome, but could you please turn off your video? Greipur, slökktu. No, that's from Iceland, Greipur Gísli. Welcome as well. And the first speaker was Minsu Jion, and as I said, he will talk about the Ayala standards, recommendations and guidelines, and some updates on documents in general. Then Julius Miller will present Guideline 1157 on web service-based S100 data exchange, and Ronald, whose the last name escaped me right now, will take G1158, Guideline 1158, on VDES R mode. And as I said, we have 4 of these webinars, so there are plenty of documents that our council has approved at its December session. So let's proceed with the first presenter. Minsu Jian is the Technical Operations Manager at Ayala. He's been with us for a few years now. And he's responsible for supporting and coordinating the work of the technical committees in general. He has a master's degree in port engineering and worked as the regional safety of navigation advisor in the Pacific community, SPC, in Fiji, where he contributed to enhancing the awareness and level of safety in the Pacific region as a whole. Prior to 2016, where he was employed by the SPC actually, Minsu has served as a radar operator in the Korean Navy and worked with Korea Institute of Astronavigation. Mr. Kulwat Singh, could you please turn off your video so we can get Minsu on the screen? So Minsu, the floor is yours.
Thank you, Omar. Let me share my screen. Do you see the screen now?
Yes.
Okay, good morning or good afternoon or good evening all. First of all, this is a new approach, as Omar said, to present the new documents of Ayala, and it is my great pleasure to take the first slot of this webinar series on the new documents. So the first thing I like to talk about is to introduce the documents approved by the last council meeting in the December last year. And I will briefly talk about the structure of the technical guidance documents. And as part of administrative update, I will introduce the catalog and MRN scheme on the publications and the documents, and the work program for this quadrennial. At the council meeting, they approved 9 new guidelines, as you can see on the screen, and they will all be introduced in a series in a month from today. The first thing I like to say is about the structure of the documents. So the technical guidance documents are in 2 folds. The first part you can see on the screen is the set of strategic documents. So there is a strategic vision document for 2018 to 2026. That is a high-level document that sets out 2 goals and 8 strategies to facilitate their achievement by the year 2026. The goal number 1 is that the marine age navigation are developed and harmonized through international cooperation and the provision of the standards. And the goal number 2 is that all the coastal states have contributed to a sustainable and efficient global network of age navigation through capacity building and the sharing expertise. And the drivers and trends, these documents are more detailed and are complement to the documents. The drivers and trend covers global maritime related trends and the expected impact and considerations on the Ayala's organizations and activities. And the position document is a living document, and that describes the position that Ayala will take technically and operationally to assist the work of technical committees and the members. So I recommend all of you to take a look at them, and they are all on the website. This slide shows the triangle hierarchy of the technical documents. The primary outcomes of each committees are these documents. At the moment, there are 65 recommendations and 128 guidelines are in force under the 7 standards. The standards are part of a framework to harmonize age navigation worldwide, and the recommendations tell the members what to follow, and the guidelines say how to implement them. Let's look at the standard a little bit deeper. You can see the symbols of the standards, and you can see 34 subtopic areas. The important thing is that they are not carved in the stone. It changes every 4 years. So I have 2 examples of this in later of my presentation. Among the 65 recommendations, the most popular one is the Maritime Vds system. It defines the types of age navigation and where they have to be deployed and what kinds of light characters they have to use at nighttime. I like to say this is not just a recommendation document. This is not just a piece of paper, but this is more on a common understanding between the mariners and competent authorities and local authorities and schools and industries since 1977. So this document is actually a 44 years old document. Ayala Guidelines provides information on the aspects of recommendations, indicating the best practices for implementation. And there are 128 guidelines in force, and a few more guidelines are under development by the committees now. So I've been talking about approximately 200 documents. And the question is, how can we see them all? The answer is this catalog. This catalog, you can find all the technical papers of Ayala, including manuals and model courses. So you can go to the Ayala website and you can go to About Ayala and Strategy. There is this catalog document. Talking about the recommendations, there are normative and informative recommendations, and I like to explain them a little bit more. Normative recommendations do not mean that they are stronger than informative recommendations. The normative provisions are those with it is necessary to conform in order to claim compliance with the standards. So the Maritime Vds system is definitely one of them. And as you can see in the photo, they should look like the same as recommended. And another category is informative recommendations. These provide those specify additional and desirable practices, but with which it is not necessary to conform in order to claim compliance with the standards. But why we follow this? Because it is proven by the members to be the best practices and the most accurate pieces of information around the world. So that is why Ayala highly and strongly recommend this, and the members follow this. In the standard structure, the sky blue color topics means it is normative only at the moment, and the amber color means they are informative, and a little bit darker color. And these are the topics contain both normative and informative. Let me show you 2 examples of standard 1010 and 1020. And what should be considered for age navigation planning and service requirements? The standards say obligations and regulatory compliance and age navigation planning and level of service and quality management and risk management and virtual markings need to be considered. And as you can see, most of them are normative and some parts of them are informative. And another standard 1040 for the VTS, when competent authorities think about developing a VTS, it is recommended to consider these recommendations. and related guidelines. So I hope you get a better idea on the document structure now. So that's the explanation on the documents. And let me go to a little bit administrative part. So regarding MRN, I'd like to talk about some updates on this MRN. For those of you who are not really familiar with MRN, MRN is an ambitious initiative by Ayala on the maritime resources. MRN is a naming scheme that can uniquely identify any maritime resources on a global scale. So this could be an organization, employees, a person, or physical, or a virtual object. So it can be basically anything. So MRN will be an essential method to identify all the maritime resource machine readable in an e-navigation environment. So the publication side, you might see this MRN as ISBN code on the paper, no, on books. So from your books, you can find this unique number of the books. So you can take this MRN for that kind of unique code. So all the Ayala publications and documents will have a unique number, and then they could be searchable by a maritime industry. That is the point. So briefly, to take this opportunity, I'd like to introduce the committee work program also. This is a kind of a work plan for the committees for 4 years. So if you want to see what documents are being developed or will be developed in this period, you can check them from this paper. On the left side, there are standards. So there are all the standards and the recommendations and the guidelines on the right side. So the amber color means these documents are in a work process of the relevant committees. And you could also check the status of the works as a street light coloring scheme. So lastly, my message is that I've been talking about many kinds of documents and publications, and they are all available on the website. So I hope you now have a better understanding of the document structure, and I look forward to seeing you all in the Ayala committees. Thank you very much, Omar. That's it.
Thank you, Minsu. Thank you for an excellent presentation. I would like to remind everybody that you can pose questions in the chat section of this meeting, and we will try to answer any question that might come up. So the next presenter is Julius Miller, who is a PhD student and research associate at the Department of System Analysis and Optimization, yeah, is the word, I guess, at the Karl von Ossietzky University in Oldenburg, Germany. After completing his Bachelor of Science in Mathematics, he finished his Master of Science in Computer Science in 2019 in Oldenburg. His research interest focuses on data management, maritime transport systems, and applications in e-navigation. So Julius will present G11 Guideline 1157, titled Web Service-Based S100 Data Exchange. Welcome, Julius, and the floor is yours.
Thank you very much, Omar, for the introduction, and also welcome to everybody here in the webinar. So you now should be able to see my presentation on your screens.
And we do.
Very good. And I'm very happy to have the opportunity here today to present a short introduction to this guideline. So to start with, in the past few years, we have seen many developments in the area of maritime services, and several services have been deployed in the public sector. For example, the distribution of navigational warnings, vessel shore reporting, or for exchanging data with vessel traffic services. And there are also some commercial services such as voyage planning, fleet monitoring, or port services. However, if we use these partially digital services, we always need ways to describe our information. And we should do this in a harmonized data model that everyone can understand when communicating and interacting with these services. So this is one reason why a lot of effort was made to create the S100 framework, which is sometimes also referred to as the Common Maritime Data Structure, and is a framework for creating interoperable data models for the maritime domain. The S100 framework itself is maintained by the IHO, but there are several derived standardized data models which are developed by other organizations. For example, on the picture on the right, you can see the S201, the AIDS to Navigation Information Data Model, which is currently being developed and maintained by the Ayala. Also, S100 has some support for web services, which are very important for our modern maritime services, and why I will explain in just a bit. So, but first, let me have a little bit on IP-based communication. And you may ask yourself, what exactly is the advantage of using the Internet protocol in the maritime environment? And one of the most important things here is that we can have an abstraction from low-level communication technologies. So we don't need to implement our maritime service for several different proprietary technologies. We only do it once for IP-based communication. Also, IP-based communication is a well-established technology which is already being used in our daily lives for years, and we are actually using it right now for having this webinar here. So therefore, we have a very high compatibility with many devices and also some very good technologies that are based on the Internet protocol. Especially when it comes to security, we can rely on common technologies like TLS. Now, in the maritime environment, it may not seem so easy to establish continuous internet access. However, we have some upcoming technologies like low Earth orbit satellites and LTE coastal stations, which have coverage of up to 100 kilometers at the coast. Also, it is possible to design our web services in such a way that they don't need to have continuous internet access all the time, depending on the service itself. So to get a little bit more specific to S100, what we can see here is the classical approach of sharing S100 data via the S100 file exchange with an FTP server. And this case is actually not using web services as such, only a simple FTP server. And this could, for example, be a chart service where a chart provider would release some chart updates, generate an S101 in this case data set and additional metadata, upload these files to a specific folder structure on the FTP server. And then on the other side, a mariner may decide at some later point in time to check for updates for his nautical charts and then contact the FTP server, log on to the server and look if he finds new data sets and new metadata for the data set. Then he would download the files and put them onto his ACDIS. So this works fine for chart data because we don't have so many frequent updates here. So maybe you would do this once a week or once a month. But what if we need to update data frequently? This can really become a problem in the setup. So if we, for example, imagine an inter-VTS data exchange with two VTS providers, VTS provider 1 and VTS provider 2, and VTS provider 2 may want to receive some positional vessel data from VTS provider 1. And to have this working in the classical way here, the VTS provider 1 always he receives a positional update from a vessel, would have to generate this data set and the metadata, upload them to the FTP server. And also on the other side, the VTS provider 2 would have to periodically check the FTP server to see if there are some new data sets. And if we are talking about positional updates in this example, you would expect this process maybe to happen a few times a second. So this can get really inefficient. We, on the one side, have the VTS provider 1 who always has to generate new data sets and metadata and upload them. And on the other side, we have VTS provider 2 who always has to request the server again and again and again to check if there's a new update. Also, there's not really a way that VTS provider 2 could talk to VTS provider 1 about the data exchange and say, okay, I just need specific data for a specific vessel. So that is not really possible here. So what we would like to have for our digital services here is a more fine-grained message exchange. And exactly this is what can be done with web services. So in this case, VTS provider would start by requesting specific data for vessels X and Y. He would like to have positional updates, but only if they are in the specific area Z. And then the VTS provider 1 would check his database and look for the requested data, and then start by transmitting the metadata once. And he will only update the metadata later if it changes. So he does not always have to transmit the metadata with the data. And then he would start with transmitting the actual data, and only if there's an update, he would push the new data to the VTS provider 2. So the VTS provider 2 does not always have to ask again and again and again for new data. And we also have some more possibilities with web services here. For example, VTS provider 1 could keep an internal state of what information has already been transmitted and only transmit the difference between old information that is already known to VTS provider 2 and the new information to make the communication even more efficient. And how to do this is exactly what is being described in the guideline. And this brings me to the scope of the document. It should give a technical overview of IP communication and web services in general, but also specific to S100 web services. Additionally, cybersecurity topics are discussed and the required software architecture and environment that is needed to get the services working are explained. Additionally, the guideline also provides guidance on the standardized service exchange of S100 information, as we have several other important documents and standards in this area which we need to be compliant with. And with the overall aims of facilitating interoperability between maritime systems or ecosystems and reducing the need to support many different proprietary designs, we could, for example, imagine a best case scenario in which a ship can interact with a port automatically, even though it is the first call of that vessel or ship to the specific port, by having standardized web service interfaces and a harmonized data model. So here's a short overview of the history of the document, which is maybe interesting to those of you who are also participating in the committees. The document was originally submitted as an input document, which was specialized only on S1 to 4. web services, which is a data model for the distribution of navigational warnings. But then the working group 1 of Gnss started to rewrite this as a general guideline on web-based S100 data exchange. In the intersessional meeting, which replaced the Gnss 25, there was some further work on the contents of the guideline, and some more related documents were referenced in the guideline, for example, the CCOM document, which standardizes S100 service interfaces. Then in Gnss 26, last changes were made and the document was finalized and forwarded to the council, which released the guideline at the end of last year. So again, here's a little overview of the core concepts that are explained in the guideline: the IP-based communication in the maritime environment, S100 online data exchange in general, but also web service-based S100 data exchange. There are also some sections on message authentication and encryption, which are of course very important regarding cybersecurity. Something on how to set up service architecture and environment for these services, and also a section on how to use sessions to make communication more efficient. Last but not least, this diagram shows the relevant standards and other documents that are related to the process of S100 web service development. And you see it is a little bit complex, and I don't want to go too much into detail here, but you see that we have several important documents released by different organizations: IHO, IEC, IMO, and Ayala. And this was also a reason to develop the G1157 to give an overview of these documents and provide guidance on how to use them in the development process of S100 web services. And this concludes my presentation. Thank you for your attention, and I will be very happy trying to answer your questions in the Q&A session later.
Thank you very much, Julius. Thank you. Very interesting. Excellent. I remind everybody that you are able to provide questions in the chat section of this meeting, and I would appreciate if you would actually write, if you have questions, that you would actually try to write them there. It's easier to understand written language than if you have to speak it on perhaps not perfect audio link. So we will now move to the third and last presentation of the day. Before that, I have to say that I'm thrilled to see 81 participants from all over the world, both Europe, of course, but indeed Asia and the Americas. I think very, very happy to have you all here. So the third presenter is Ronald Roeliff, who is a senior researcher and project manager at the Institute of Communications and Navigation of the German Aerospace Center, DLR, in Wesseling, Germany. He received the Dr. Ing degree from the University of Erlangen-Nuremberg in Germany in 2008. He has been a visiting researcher at the City University of Hong Kong in September of 2004. Ronald initiated and coordinated 2 European Union funded projects titled Where, like in Where, and Where To. I don't know these projects, but the titles sound very interesting. And I wonder if we know where he is now. We are ready to deliver the presentation. But Ronald holds numerous patents in the area of mobile communications and radio-based localization, so he has done a lot of work in this field. And his current research interests include various signal processing aspects of mobile and maritime radio communications and localization. So Ronald will speak about Guideline 1158 on VDES R mode, range mode. The floor is yours, Ronald.
Thank you very much, Omar, for the very kind introduction, and welcome everybody for this recently approved presentation, or actually about the recently approved Guideline 1158 that I would like to introduce you to. So I presume you can see my screen. And at the beginning, I would like to introduce you, or I would like to give you some motivation why we believe and why we believe this is relevant. We are all aware of that there are different position and navigation and timing systems, and explicitly there are 4 currently working and operatable global navigation satellite systems. In the US, it's GPS. In Russia, it's GLONASS. In China, it's Baidu, and in Europe, it's Galileo. And there are even 2 more that are currently developed. They are currently operating already as a regional system, but now they are also aiming for a global approach in India and in Japan. So what does the GNSS system provide? Actually, it provides you with radio signals to determine the position that we then can use for navigation. And it also provides you with timing information that we will use for synchronization, for instance, in systems such as AIS or other electronics on board. And as we may remember, normally GNSS just works. There's hardly anything that we are really concerned about. It's basically as safe, as reliable as the sun that comes every morning up. But nevertheless, people have actually thought about is it, or how crucial is actually the dependency on GNSS, and what will happen in case GNSS fails. And in the UK, they did about 4 years ago, 2017, a study to assess the economic impact on the UK in case a disruption of GNSS occurs for 5 days. And they did that for the whole society. So they covered the road, they covered the emergency and justice services, surveying, also rail and foot. And as you can see here in the bottom, the maritime part actually was covered, or actually addressed, up to 21%. And the reasons for that, what they found out was that there were actually expected severely disrupted ports. Explicitly, the loading and the unloading of containers will actually be delayed, and that will then have a knock-on effect for factories that rely on just-in-time delivery. But also in the ports, all the transport operations, they lose all the efficiencies that is brought by GNSS. In addition, and that is the crucial part for the ship part, is also that the GNSS provides information that is used by the ship's clock, by the ship's radar, and by the compass. So therefore, this has a severe impact. And then the question was, well, is there a backup system in case GNSS is disrupted? And in this report for the maritime section, they actually conclude that GNSS is the primary source of all navigation information. And the alternative source for navigation is basically that you look through the window. So there is nothing else. Here, what you can see is a non-exhaustive list of maritime applications that actually rely on GNSS. I won't go through, just as a reference. And how can we actually imagine that GNSS is really disrupted? What we do know is that GNSS is received as a really weak signal because simply the satellites are so far away. And therefore, there are approaches where we can fairly easily fake GNSS signals. This is called spoofing. We can also do something less intelligent where we just place interferers intentionally. For instance, that is then called jamming. Or we may also have some infrastructure that sends out pulse signals with high power, like for instance here at the airports. Or here we have these TV stations that actually also may even cause some harmonics that will actually interfere with the GNSS signal. And of course, we have the atmospheric effects that we cannot control at all. And the core focus on the maritime part is that we have these fake GNSS signals that were spoofed, or we have jammers that actually make sure that the GNSS signal is not reliably received at all. And my colleagues from a neighboring department in our institute, they put actually a receiver on board of a cargo vessel that was traveling for about 8 months, from May 2017 till February 2018. And it actually measured at different harbors that were like such as Rotterdam, where it all started, but also went on to Hong Kong, Shanghai, and Singapore, and so on, and Hong Kong back. And what they recorded were snapshots where you could see that there was the radio frequency interference occurred. And what they also found out is that despite the fact that they visited these locations multiple times, the threat was consistent. They further also found out that the harbors, to some extent also the coasts, were the most critically ones, but they even also found out that some events actually were detected in the open sea. So as you can see now, to summarize, that GNSS is extremely reliable, but it's also vulnerable. And therefore, the request of a backup or an alternative PNT system is there. And this is where it comes in for VDS R mode. And this is the outline of the remaining talk. I will present you some, or I will mention some other radio communication systems that are used for navigation. I will briefly outline the requirements that we have found in the literature and that we intend to use. And then I will briefly go through the Vds R mode guideline 1158 and finally summarize.
Ronald?
Yes.
I see that you have plenty of slides left, and what we are seeing is the presenter part of the presentation.
Oh.
Maybe you could share another window.
Yes.
That is better. Thank you very much.
Okay, sorry for this. Okay, so you saw this. Okay. I have some backup slides, so don't be too concerned. So first, let me browse through why are we using a radio communication system to navigate? Because it's explicitly a system that is dedicated for communication purposes. And GNSS is normally a dedicated system that is explicitly for navigation. So why do we want to use this? Well, if we look into what other radio communication systems exist, for instance, in LTE, they explicitly added some positioning reference symbols to allow the users or the network or the users, and at the end, this is determined in the network, to determine the position of the mobile user in case he makes a 911 or a 112 call, so an emergency call. So they explicitly address this by adding these positioning reference symbols inside the LTE standard. The same is actually now also taken over for 5G. So therefore, the idea was that we actually make use of a terrestrial communication system such as VDE and try to integrate that and try to have an application that we can use for navigation. So what are the advantages? VDES is standardized with a worldwide frequency allocation. VDE terrestrial offers actually 100 kilohertz, for instance, compared to AS, where we have just 25 kilohertz. This is important because more bandwidth means better resolution or a better accuracy. And VDES terrestrial or VDE terrestrial covers explicitly the relevant areas like coastal and harbor areas. So therefore, we would like to utilize VDE to set up VDS R mode as a navigation application inside the VDS communication system. And we also would like to make use of the communication system, as you will later see, to accommodate additional navigation data that needs to be transmitted as well. And also we would like to make use of the authentication schemes that are defined in VDS. So what are the requirements, the user requirements on a PNT backup system? There was an IMO resolution A915 some time ago, and out of this there was a development of Ayala R129. And this looked into the different maritime regions, such as the ocean, coastal, port approach, port or inland waterways. And they were linked with system level parameters, such as the accuracy or the integrity, and some service level parameters, the availability over a certain period of time, such as 30 days or 15 minutes. And also, of course, the coverage itself, and how long we actually would need to fix the interval. And when you can see here that, for instance, the ocean for a terrestrial system, that does not seem applicable, therefore we can exclude this area, or we have to exclude this area. The same is also true for the port, inside the port, because 1 meter seems not really, the 1 meter accuracy seems not achievable. That is not even achievable for a normal GNSS system. So therefore, these two, ocean and the port, are excluded, and we just focus on the R mode service area, such as the coastal, the port approach, and restricted waters, and also consider inland waterways. Now I would like to dive a bit more deeper into the Ayala Guideline 1158, Vdes R mode. So R mode, the R stands for ranging, and ranging is basically the determination of a distance between the transmitter and the receiver. The Vdes R mode actually makes use of the IMO e-navigation architecture. So here on the left side, you can see the ship side, which actually takes as an input the PNT data provisioning, such as GNSS that comes from GPS, GLONASS, Galileo, and also Baidu. And here on the right side, we see actually the shore side, where such a system, for instance, as a terrestrial backup, such as R mode, can be built up. And R mode can currently, what this guideline is focusing on is the VHF part. Inside the Gnss group, people are also focusing inside working group 3 on the MF R mode. And all this is actually covered by this, again, IMO e-navigation architecture. So we have defined the logical architecture. That's rather straightforward. So here on the bottom, you see the command and control and security center that is in communication with the R mode transmitter station. That is basically the base station of a VDS system. It also has an R mode reference time that is normally connected to an atomic clock that is co-located to a VDS base station. And then we also were considering R mode VDS, R mode monitoring stations that actually control if the transmitted signal of the VDS R mode base station is transmitted in a reliable way and regularly. And then here on the top, you can see the R mode receiver, the user, which is then the vessel. As I said, VDS R mode wants to provide a position, but also wants to provide a time. And VDS R mode provides the R mode system time. And the system time is therefore is relevant to have a traceable, that it's traceable to UTC. So we have to consider offsets and uncertainties. And this kind of information that we have the offset and uncertainties towards GPS, Galileo, and Baidu time, and as well as the GLONASS time, and as well as UTC, is measured and is communicated also within the system. So we have an R mode system time itself in case GPS, Galileo, Baidu, and GLONASS fails. And then we would take over with the R mode system time and would connect that to UTC, which is relevant for a lot of maritime applications. What we did is we actually defined the R mode signals. And for this, we did some research that we actually were trying to, that I would like to show you now. So what we did is we tried to utilize the Vds communication system, which actually complements and also comprises the well-known AIS. We actually use here the terrestrial VDE, which operates at a carrier frequency of 161.8375 megahertz. And we use a linear modulator with pi over 4 QPSK. So that is a classical modulator that is inside the VDS, the VDE terrestrial system. So there's no explicit change of the ranging sequence. And we designed this ranging sequence, and we looked into how we can actually design this. And what we found out is that we can concatenate two different sequences, and we can concatenate them based on this gamma factor that we set as something that we can define depending on how the environment looks like. And what we can actually see here is the 10/1, that would be the 10-meter accuracy for a range link. This is more or less here our operational range. So between the 30 and the 60 dB of received signal strength, or actually ES over N0, so SNR. And we actually looked into this and tried to optimize this. And then we found out that an alternating sequence together with a PN sequence gave us actually a good performance depending on this received SNR, as I just showed you. And to make sure that, to understand what is the benefit of the alternating sequence, the benefit is that we actually increase the sharpness, which would give us a benefit in the accuracy. The benefit of the PN sequence is that we reduce the ambiguity. So these hills here get wider. That means, and the neighboring ones are actually getting significantly lower, and therefore we have less ambiguity. If we use the alternating sequence, we get a sharper one, but we have also neighbors. And in case we have a significant error, we may hook up on the wrong peak here, and then we have a significant error. And this is the trade-off between ambiguity versus sharpness. And this is what we actually covered by this gamma factor and concatenating these two sequences. In addition to this sequence, we also have navigation data that is very similar to GNSS data, but in VDSR mode, this is not incorporated in the ranging sequence, such as in GNSS. We actually would like to use the VDE terrestrial 25 kHz channel, which is a specific data channel that is explicitly selected for large coverage areas. And inside this navigation data, we have we spent bits for the R mode system time. We spent bits to convert to UTC. And we also spent bits for each of the clocks to make sure that inside each clock that we can actually trace the clock. And therefore we describe with 26 bits how the clock actually changes from each time step. Then we have some validity and signal health status in the network. And of course, what is super crucial is that we need to know where the base station is. So we have here the coordinates of the phase sender of the transmitter antenna, plus an ID. The ID is related to a specific base station. And then we have here the gamma factor for these, which kind of ranging sequence at the end we are using from which base station. And all this sums up to 331 bits. A pi over 4 QPSK 25 kHz channel has space for 432 bits, so we still have 101 bits that we can think about future use. As I said, we want to make use of VDE terrestrial, and VDE terrestrial has a MAC layer resource allocation scheme, which is a TDMA scheme, a time division multiple access scheme. And each of these time slots is 26.67 milliseconds, such as also an AIS long. And we are intending here to transmit from base station one ranging sequence, afterwards from the second base station, and then from the third base station. This is actually repeated every second. So every second we transmit the same ranging sequences again and again, and in between we have plenty of space for other communication services. And we also need to communicate the navigation data. And there we thought about doing that every 60 seconds. And that is communicated here. And this is the solid blue box here. Then to make sure to understand what's the difference between the VDS communication system and the VDSR mode. A normal communication system just covers this communication area. But the signal itself can be also received outside of this communication area, the ranging signal. And it also needs to be received from not just one base station, it needs to be received from multiple base stations to make sure that we can determine not just the range, but also the position. And in addition, therefore, because it's outside of this communication range, the navigation data can be provided either, for instance, by this terrestrial base station, or also, which is not yet fixed, but this can also be, for instance, considered from the satellite in case he comes regularly apart. So then we did some validation last summer at a lake here in Bavaria, where we set up 3 base stations around this lake. The base station basically looks like a 10-meter mast that is co-located to a GNSS antenna. And here we transmitted the different ranging sequences with a 1 watt transmit power. In VDS, officially, we can have at least 12.5 watt plus some antenna gain. So here we were just limited to 1 watt. And we used this rescue boat. The rescue boat has a nice pleasure effect that, well, you have your rescuers already next to you in case something happens. And it can actually speed up to 60 kilometers per hour. And this boat was actually accompanied by a touristic vessel that also caused some blockages from one side, for instance, here from Buch. And then we here in the middle, on the right side, you can see the performance of the absolute positioning error. And we start with basically 0, and then we increase tremendously here with a high error that could be caused, or that is caused, for instance, by this large vessel. But then after this vessel is gone, we can see that our error actually, our positioning error, fluctuates around the 10-meter error line. So we can be a little bit better, up to several single-digit meters, or a bit worse than 10 meters, for instance, 12, 13 meters. So what other ongoing developments for alternative PNT systems exist? In Europe, there's the R-Mode Baltic project. They are currently setting up an R-Mode testbed in the Baltic Sea until this March this year. And hopefully then we can actually make a demonstration of R mode for the MF, but explicitly also for the Vds R mode, and to understand if we then fulfill the maritime user requirements as a backup system that I have outlined to you. In the US, there was from the past president, the past President Trump, there was a statement to develop an alternative PNT system. So there was a decree, and that is still valid. And therefore, they are looking for an alternative PNT system and to develop that. And VDS R mode is one of them that they are considering. There's Korea, which are developing and building up an R mode infrastructure, VDS and MF. And the same is also for China. They're also developing and building up R mode infrastructure for VDS. And there were more countries that actually came out and showed interest at the R mode workshop about 1.5 years ago. So therefore, there is a definite need for alternative PNT systems and explicitly also for the maritime world. And VDS R mode, as this guideline, is a very valid solution. What I want to show, this is guideline 1158 that covers the VDE part or the VHF part. There's another currently ongoing activity in the ENGE group, which addresses the MF radio beacons. Their advantage is that they have a significantly larger range. The performance is slightly worse, and they have a significant performance loss during the night. The interesting thing would be that we can actually combine these two to complement them and to increase the coverage. I mean, the VHF coverages are maybe 30, 50, or maybe even up to 100 kilometers. But if we go beyond, then we would love to rely on some other, and for instance, the MF radio beacons to make the VDE system more reliable. So to sum up, VDS R mode provides a navigation application for VDS. So we can utilize the VDS. VDS is also currently in discussion, or actually in the approval procedure at the ITU-R Working Party 5B to become M.2092-1. That will hopefully happen either this or hopefully then latest next year. It respects the available resources in this VDS communication system. So there's still resources for many other communication services available. It's a scalable navigation system that basically means there's no limit in vessels, and it goes beyond the known terrestrial VDE coverage. The vessel itself requires just an upgraded VDS receiver that allows to exploit this ranging sequence. In case it doesn't have this capability, that doesn't mean it harms the other VDS receivers. It just won't make any use of the R mode signal. The shoreside requires an atomic clock or a very precise clock that can be traced. It will broadcast regularly with a 1 Hz update rate, the ranging sequence, and it requires a VDS network that is, for instance, served by a provider so that we have a synchronized navigation data also to the vessel. So with this, I can say that the VDS R mode system will support the Mariner with electronic navigation with at least 100-meter accuracy in coastal navigation, and maybe even up to 10-meter accuracy for port approaches. And with this, I would like to thank you, and I'm open for questions.
Thank you very much, Ronald. Excellent. And your final statement there is very, very encouraging. Thank you for that. So now we have reached the question and answer session. We only have a few minutes left of the planned duration of the webinar, but still we have room for a couple of questions. If you have a question, you may raise your hand with the hand raising functionality in the system. And I have a couple of questions or comments from the chat, which I will list. The first one, perhaps relevant for you, Ronald, was the question from who posed the question? Valtteri Elaine. How does the R mode Baltic project link to the VDS R mode? But you had something on it. Can you say a couple of words on that?
Yes, VDS R mode is considered in the R mode Baltic project, but the R mode Baltic project also addresses the MF R mode, and they do that also very, very intensively. This is how it's connected. So yeah. We as DLR, we are part, or actually my colleague Stefan Gwies is leading this project, and I'm as a colleague, I'm also participating in this.
Excellent. Thank you for that. There was a question about the MRN, Maritime Resource Name, from our former president, I think, Mr. Ribolio. But Minsu replied to that in the chat. And the fact of the matter is that there's a future session where webinar where we will address the MRN further. There's a time slot for that at a later webinar. Then there was a question on the procedure for participating or joining the Ayala committees, also answered by Minsu in the chat, but I want to reiterate that the committees are the workhorse of Ayala, and we welcome every member of our association to these committees. So that means that staff members of our member organizations are more than welcome. And we need you. Without the workforce or the work that happens in the committees, there is nothing. Everything stems from the committees, basically. So the procedure for that is that you actually you create an account on the Ayala website, and then there will be a vetting process where we check that you actually are within the membership, and then you can register for the different meetings through the website. Then there were some comments about publications, accessibility of publications, and the time taken to publish them actually after they have been approved by council, and it takes some time before they are published on the website. Well, one of the comments, it's also answered in the chat, but one of the comments I would like to make is that we have a quality assurance procedure so that we ensure that the documents are publicable. The council approves the documents, but there may be some typos and editorials that need to be fixed after that. So it takes a few days at least for us to make them available. I think that was it. Let me see if there's anything else. I see no raised hands. And well, Minsu mentioned something, but I don't understand the question. Something about public-private keys, cybersecurity, and things like that. Would you like to express your question, Minsu, to the audience?
Yeah. Do you hear me now?
Yep, we hear you.
Okay. Yeah. I had a question to Julius. That we are using the web-based communications. I think for the security side, I think you mentioned that we could use the benefit of TLS. So as long as I understand TLS, the service providers need to be prepared for the communications. So such as public keys and private keys, all these kind of things. So I mean, definitely, the service providers need some technical expertise on that area. So from your presentation, we saw the communication between VTS. So I think the VTS authorities need to be prepared for that. Is that did I understand correct your presentation? Thank you.
Yeah, thank you for your question, Minsu. And I think you understood correctly that if using TLS, we would need to have something like a private key infrastructure. But this very technical topic can possibly be moved away from the service provider to other services who aim at providing this specific public key infrastructure. And we also already have some operational services which rely on the business model of providing such public key infrastructure based on the Maritime Connectivity Platform. And you may also have heard of the Navilink platform, which is also based on the Maritime Connectivity Platform. And they have actually this set up as a business model to take away all this technical expertise that is required for setting up a public key infrastructure and providing this as a service to other service providers.
Okay, thank you for that, Julius. We have a couple of questions. This one is for for Ronald. Happy to hear your presentation. This is from Anders Bergström from Sweden. Hello, Anders. Good to see you here. Happy to hear your presentation and that you hold several patents. That should make you understand the importance of protection of intellectual property for things. You then might also be aware of patents related to R mode that exist already. Those patents are now under declaration to the ITU for not being available for use. So a standard cannot be made. Do you have any comments on that, Ronald?
I am actually not aware of any patent that could limit Vds R mode. So, but I would love to see them.
Yeah,
I would love to see them.
So would I. Anders, I think I think this topic is too too vast to discuss here with limited time available. But the general notion within the work that we're doing in Ayala is that we don't know of any patents that actually that we are infringing or it's a problem for the technical work that we are doing. This is correct or not, right?
Yes,
Yeah.
and the work that we have done, there is nothing that is protected.
No, that is our view.
Yeah.
If you have something some different information on us, then please let us know. And the other question was about, I think it's about geometry, because it's again from our former president, Juan Francisco Rebolo, who asks if establishing R mode on the coast is appropriate for Spain or Portugal or Canary Island, where they have no country in front, he says, but it would be a difficult thing to have proper geometry there, unlike the Baltic, for example. Ronald.
I do agree. The geometry, or in what is the relevant word there, is the GDOP, the geometric delusion of precision, that has an impact. What we also have learned in Norway, they have in front of their coastline, they have oil stations or where they have platforms, oil platforms, where they actually can also, and where they also can actually add a VDE base station, and they're interested in doing so. And they actually gives you a significant advantage in respect to GDOP, because they are maybe 30 kilometers out in the ocean. How that fits for Portugal, I don't know. But GDOP is definitely something that needs to be considered. Yes, I agree.
Yeah. Yeah, this was one of the limitations that I actually identified myself with the MF beacons, using the MF beacons for this, because they're actually quite far apart, and they're not ideally located for the geometric required geometry in a system of stations. So that's a challenge. But a combination of MF R mode stations and VHF R mode stations could be a possibility, we think.
Yep.
I see no raised hands. I see a comment on the availability of G1089 provision of a VTS that is not to be found on the website. We will look into that, Ellen. Certainly, all the documents should be available now. There might be a slight hiccup there. There will be a future webinar on the outcomes of the VTS committee work. And there will be, for each committee, there will be a webinar actually. And the next webinar that we are planning is on the 18th of February, which is the output of the engineering committee. So please make a note of that in your calendar, the 18th of February. recommendations and guidelines coming out of the engineering committee and approved at the last council meeting. Now I see Barry Goldman is commenting on 1089. Yes, of course, that reminds me. The 1089 is a document that has been approved in principle by Council, with the caveat that it cannot be published until the IMO has adopted the new 857 VTS resolution. And therefore, we of course haven't published it on the website. So it will be published in due time when the resolution. It's a preparatory work to be ready when the resolution is adopted. Then we will publish that one and others which we are preparing until then. Yes, I was saying 18th of February. Since there are no raised hands or no questions, I will proceed to close the webinar. I must thank the presenters, of course, for their excellent presentations. And you will see from the presentations given that this is highly technical work. These are technical committees, and there are world experts in these committees that contribute with state-of-the-art knowledge and principles. So it's a great place to be if you are interested in these things, at the forefront of everything. I have to thank all of the participants for being here, showing up and showing interest. We had 80 participants, and I'm very happy about that. And there will be an opportunity to review the presentations on the YouTube channel, where we will publish the recording of this webinar. So, in conclusion, I hope that all of you and your loved ones can steer clear of the ugly virus. Keep your distance and keep well. The webinar is closed. Thank you all.
Thank you, sir.
Goodbye.
Bye, sir.
Bye-bye.